Okay, limits. Remember, the only discontinuity that has a limit is a removable. So -3, this is my -3, which is an infinite. So infinite can be D and E. Now, only because both sides of the infinite are in the same direction. Remember, it's only D and E when they don't agree. Some professors will also accept positive infinity. Okay, so the answer is D and E or positive infinity, only because both sides are going in the same direction. If both sides were going down, we could also say D and E or negative infinity. But if they're going opposite directions, one side up, the other side down, is just D and E. Okay, then we have -5, which is here. We have a removable. So the limit is, where is the graph? The graph has that open circle. Where is the open circle? The open circle is at y=2, so that is my limit. Negative infinity, that's here, and this is kind of negligible, but it appears to me that it's going straight out. It doesn't look like it's going down. It looks like it's approaching an asymptote of 0, so that's why I put 0. Okay, +2, we have a jump. Remember, jumps don't have a limit, so that is D and E. Okay, E and F are asking about the closed circles. The closed circle or the graph. So f of -5 has a point here, and that's 1. -1, that's right here. So if I were to go here and put a point, I mean, it looks to me like it's about 1.5. Now, I know this is not on the in my questions. I'm going to add it for next year, but let's talk about f of 2. F of 2, that's where my jump happens. I want you to notice that both of these are open. So that means f of 2 does not exist. So if I were to ask that, and there isn't a closed circle, it would be D and E. Okay, question 8 are asking, where are my discontinuities? So I have at x equals, I'm just going to go from left to right. At x equals -5, I have a removable. At x equals -3, I have an infinite. And at x equals +2, I have a jump. All right, so let's talk about end behaviors. So on the ends, both of these are doing the same thing. It looks like it's approaching an asymptote of -1. So the limit as x approaches plus and minus infinity of f of x is -1. The second one, both arrows are doing the same thing. They're going down. So the limit as x approaches positive and negative infinity of f of x is -infinity. All right, now we have an odd degree and they're doing different things. So let's start off with the left. The limit as x approaches -infinity of f of x is -infinity. That's the left. The right, that's here. The limit as x approaches positive infinity of f of x is infinity. Okay, and our last one. Looks like we have a bottom heavy function. So this graph is a bottom heavy. And we have our end behavior, looks like it's approaching 0. So the limit as x approaches positive and negative infinity of f of x is 0. Okay, so now let's talk about graphing. Now this is a big part of the test. You have two graphs. So First thing you should do, and again, I recommend you pause the video, work it out in pencil. If it's wrong, go back and correct it. But you need to try to do these on your own first, and then come back and look at the solution. First thing I'm doing is factoring. That should always be your first step. Put this here, actually. Okay. So I actually do have a factor that goes away, and it would be x plus 1. So to find the ordered pair for the whole, I'm going to take this factor, which is what I'm going to remove. That's why it's called a removable. So I'm taking this factor, I'm setting it equal to 0. That's going to give me -1. Now for every other piece, now that I have removed that factor, I'm going to use x plus 2 over x minus 3 to answer all of my questions from here. So when I plug the -1 in to this remaining equation, I get a decimal. I get -1/4. Let me verify that. -1 plus 2 is 1, and that -4. So I get -1/4. Let me go over to my graph at -1. I'm just going to put an open circle in between the 0 and -1. Okay, the roots, that's the same as x-intercepts. That always comes from the top. Take the x plus 2, set that equal to 0, you get -2, 0. Put that point down. The vertical asymptote, this is balanced. So we're going to divide our leading coefficient. So that would be y equals 1. And I'm going to go ahead and draw that in. I'm going to use blue highlighter. Oh, going the wrong direction. Okay. Let me pause. I'm going too fast. Pause. Pause. The vertical asymptote comes from your denominator. Okay. Your denominator is x minus 3. Set that equal to 0. And we get that we have a vertical asymptote coming from this x minus 3. That's how you always find this from your denominator. So we get x equals 3. So now I'm going to draw in my vertical asymptote at x equals 3. I'm going to just use the blue. Okay. So my end behavior, because this is balanced, I'm going to have a horizontal asymptote. So we don't have a slant. We only have a slant when it's top heavy. We have a horizontal. You can't have both. And to find that, I'm dividing my leading coefficients. That's where I'm dividing 1 by 1, and I get 1. Lastly, my y-intercept, substitute in the 0. You should get 0 and -2/3, which is really just right next to that removable. We're just kind of coming in even closer. So that's just kind of like right here. Okay. So from here, I mean, we can kind of finish it out. We know that it always starts in coming close to the horizontal. I'm going to make a slight turn. And then I'm going to come in and get really close to that vertical wall and just fall down. And I would just pick a couple of numbers, and you can choose what numbers you want to use. I'm going to pick 2 numbers over here. And the numbers that I chose were 4 and 8. And when I did that, I got 6 and 2. So when I plot that, 4 up 6, 8 up 2, and we just draw it out. Okay, let's go to the next page. And let's talk about a special, because of this -3. So nothing is going to cancel. The roots, because it is special, I have to do it differently. So I'm going to take and set this equation equal to 0. I'm going to solve it. Again, pause the video. Add the 3. Multiply. Distribute. Subtract. And divide. So I got -3, 0. I'll go ahead and plot that down. Vertical asymptote will always be your denominator. So that's x equals -2. My end behavior, because it's special, we have to do that differently. So it's balanced. So I'm still going to divide the 1 by 1. So it's y equals 1 over 1, but I have to include that -3. Again, this is horizontal. It's not a slant. So y equals 1 minus 3 gives me y equals -2. Substitute in the 0 for x. 0 divided by anything is 0. 0 minus 3 is -3. Okay. Let's go ahead and plot these points and graph it on out. Plotting my horizontal at -2 and my vertical is at x equals -2. So I picked a couple of numbers. Let me go ahead and give myself a little bit more space. Okay. The numbers I chose, and again, it's up to you to pick what you feel like you need in order to graph it. I use -8, and I got +1.7, or about 2. And then I used +6, and I got -2.3. So when I graph those in at -8, I'm right above my horizontal asymptote. So I'm going to come in close to that horizontal, make a slight turn, crawl up the wall. 6 -2 is -2.3. So at the 6, we're right under the asymptote. All right, so I'm going to come up, crawl in the wall. I'm going to make a slight turn and go straight out. Okay, let's talk about a slant. Don't have any holes, nothing cancels. Now, the first thing you should do anytime you see a quadratic is factor. Two numbers that multiply to be -6 and add to a +1 is +3 and a -2. Okay. So I'm going to set both of those factors equal to 0. Both of these equal to 0 to get my two x-intercepts. So I got one at -3 and +2. Vertical asymptote always comes from the bottom. If x plus 1 equals 0, then x equals -1. I'm going to draw that in. Okay, this is top heavy. So we don't have a horizontal, we have a slant. I'm going to come back to that. And then my y-intercept, that's what you get when you plug in the 0 for x, and that is actually going to be -6. Let me plot that. Okay, so let's talk about the equation for the slant. Go ahead and do synthetic division. I'll put my vertical asymptote on the outside, and then I'm going to list the coefficients, 1, 1, -6. You always bring down the first number. That first number is your slope, or m. -1 times 1 is -1. I add and I get 0, and that's my y-intercept, or b. So the equation for my slant is y equals 1x plus 0. And yes, you could also just say y equals x. Okay, so I need to graph the line y equals x. So I'm going to start with my y-intercept, which is 0. And then I'm going to go up 1 to the right 1, put a point. Up 1 to the right 1, put a point. And I'm just putting a whole lot of points because I don't have the ability to put down a ruler. I want to make sure my slant is perfect. I want it to be in the exact spot. Then I'm going to go the other direction and do the opposite. Go down 1 into the left, down 1 to the left, down 1 to the left. Okay, I'm going to keep going, and let me draw that in. So I really have enough. I know on this side I'm going to come up, make a slight turn, and then roll up the slant. I know you can't really roll up, but that's what you're going to do. On this side, I didn't really have a lot, so I put in -8. And when I put in the -8, actually, I think I put in more points, but going back, I really only needed to put in -8. So if I put in -8, I get -7.1. So -8, go down 7. So I'm really just, again, I'm right over the slant. I'm really kind of verifying. And that helps you verify your slant is in the right spot. Because if you substitute in a number and it's not above or below where it should be, then that can also be an indication that the equation you came up with for your slant is wrong. Okay, our last question, and we don't need to graph it. First thing we're going to do is factor. I'm going to pause. Go ahead, pause the video so you can factor. Two numbers that multiply to -10 and add to -9 are -10x and 1x. So I can take out a 2x and a +1. So that would be my first factor. And then I can also take an x and a -5. Okay, so I'm going to use this equation now to find my answers. So because I have 2 factors in my denominator, I have 2 vertical asymptotes. So I'm going to set 2x plus 1 equal to 0. And I'm also going to set the x minus 5 equal to 0. And what I'm going to get is x equals -1/2 and x equals +5. Those are my 2 vertical asymptotes. This is bottom heavy. So we don't have a slant because this is only a slant when it's higher on the top. So that's NA. And anytime it is bottom heavy, you don't need to do anything. Bottom heavy, horizontal asymptote, y equals 0. This is not a special case, not a special case. So to find my x-intercept or my root, I'm just going to take the x plus 3, which is in my numerator, and set that equal to 0, and I get negative 3, 0. And lastly, for your y-intercept, substitute in 0 for x, and you should get 0 and then negative 3/5. Okay, I hope this was helpful. You can do it. Test coming up.